extended it out to 37 years. We started with $1,000, and over those 37 years it's grown and grown at 7% per annum, compounded annually, and this is what we see. The shape of this graph is just what I want to bring to our attention for today. We've been dealing a lot with linear graphs. What do we mean when we say a linear graph? What does it look like? It's a straight line. Yep, it's a straight line. A linear graph will have a straight line like that. Now we can see this is not a straight line. If we were to draw a line that was the top of all of these columns, something like this, that is not a straight line, obviously. What kind of graph is that? Does anyone know what it's called? What that one is? This is called linear. What is this one called? Does anyone know? This one is called exponential. An exponential shape of the graph. And it's an exponential one because it is of the form, if we were going to graph it with y's and x's, y equals a to the power of x. And often when we have graphs, we have our x is not in the power. So we might have y equals x squared or y equals x to the 4, that kind of stuff, but the x is not in the power, it's the base of the number. An exponential one is where the variable, the x, is in the exponent, the index, the power. Okay? And so that is what we call an exponential. And I guess the defining features of these graphs is that the bigger you go, the steeper they get. And so if you were to extend, well, I've done this out to 37, if we were to go out to 100 or 1,000, it will just keep getting steeper and steeper and steeper. And it will get to a point where it almost looks vertical. It never does get vertical though. It will look almost vertical, but we'll never get there. And even at this end too, and again, we're not going to see it here too much because we've started at this point here, but if we were to kind of extend it this way, and keep getting smaller, in fact getting negative numbers, and so this one here is x equals 1, x equals 2, x equals 3, 4, and so on. Now if we keep going this way, x equals 0, and negative 1, and so on, the graph would flatten out, and again it would look like, if we went as far negative as we wanted to, negative 1,000, it would look like it's gone completely horizontal, but never, again, just like at this end, never gets completely horizontal. It will look like it, but will never get completely horizontal. It will always be going down slightly. That is the nature of an exponential graph. And so when people talk about something is increasing exponentially, people might talk about, pollution is increasing exponentially, or inflation is, or whatever, whatever people talk about in a society-wide situation. What they mean is that thing just keeps going up and up and up, faster and faster and faster. That is what they mean by exponentially. Okay, and that's where this comes from. It comes from this graph where the x or the variable is in the exponent, in the power. And so as that x gets bigger, this thing gets even bigger and bigger and bigger again at a faster and faster rate. Okay? Compound investments are exponential things. As you have your investment longer, it grows faster and faster. Okay? As you invest longer, it grows faster. Each year goes up more than the last year goes up. That's the nature of exponential, that's the nature of compound interest.